Okay, so today what we're going to be focusing on is solving rational inequalities using a graph. Okay, so we're going to be paying attention to the graph and using it to solve an inequality. Now, when we solve an inequality, notice this is a one-dimensional inequality because there's only one variable in this inequality. Okay, so when we solve this, the solution that we're looking for is a set of x values. Okay, so we're looking for a set of x values. So, what is the graph of x over 4 minus x going to look like? Yeah, that's going to be a rational graph, so it's going to have the curves. How do we know? Yeah, there's an x in the denominator that has a degree of at least 1. Okay, so what I want you to do is pick a color to represent the left side. In this case, we'll just call that y1. And as best you can, I want you to trace or highlight y1, or the rational curve, in that color. Okay. What's the graph of 3 look like? Horizontal line when x is equal to, or sorry, when y is equal to 3. All right. So what this is asking us for is for what x values is, in my case, I chose green, but depending on what color you chose. So for what x values is my green graph less than, in which translates to above or below. So for what x values is the green graph below the pink graph? That's what we're asking ourselves when we try and solve this. Okay? For what x values is the green graph below the pink graph? So here's my pink graph. Here's my green graph. So would you agree for this piece? And for this piece, we are below the pink line. Yeah? Okay. Now, we have to use a little bit of our knowledge of rational functions to help us out just a tad. Where does this rational function have a vertical asymptote? Okay, as an equation? Yeah, x equals 4. A vertical line at x equals 4. So we need to make sure we are paying attention to that, because that is going to adjust our answer. All right, so what x values, if we come up with our solution, what x values are going to make up this piece? Okay, hang on. So negative infinity, good. Up to 3. Where are we getting the 3? Yeah, that's the intersection point. My highlighting didn't go perfectly, but you can see it a little better on your graph. Okay, so negative infinity to 3. The 3 is going to be a parentheses because I want to know when the rational is below 3, not below or equal to 3. Y'all see that? Okay, union. My x values are going to pick back up on the other side of my vertical asymptote. So we would start at 4, and your vertical asymptote's always going to have a parentheses around it, because remember, we can never hit it. So from 4 to infinity. We know that this graph's never going to go up and cross that pink line again, because we know if we look at this, the horizontal asymptote We have a degree of 1 over a degree of 1, so the horizontal asymptote would be at y equals -1. So that's where that graph's going to tend towards. Okay, so here is our solution. Questions? Okay, let's look at number 2. We're going to start by doing the same thing again. The colors really help me visualize what we're comparing. Not, of course, going to force you to use the colors, but I think they do help. So I'm going to choose to highlight the rational expression in green. And then I'm going to highlight my linear function in pink. Okay, and before we go too far, I want you to please add an equal to sign right here. I just want to practice that one time where we have it equal to. So please make it less than or equal to. Okay, so this translates to for what x values is the green graph below or equal to the pink graph? So on your paper, take a second and try and circle the areas where that's going to happen. What's important for us to notice, okay, horizontal will help us a little bit, but what's going to help us even more?
Vertical.
Yeah, the vertical. Good. Yeah. So the vertical asymptote is at x equals 1. So it appears to me that we're looking at this section right here and this section right here. Do you guys agree with that? All right. So if we were to write our solution, we're going to start at our intersection point. What's that x value? -1. And since we have less than or equal to, what do we want around -1? Bracket. So -1 up to what x value? 1 for a vertical asymptote. Parentheses y. Okay, you'll never, ever, ever cross a vertical asymptote. Union. Two with a bracket to infinity. Questions? All right, flip it over. And give number 3 a try on your own. Okay, so hopefully you drew in your vertical asymptotes. Where are your vertical asymptotes? Good. So x equals -3 and x equals 2. That's going to help guide our answer. So for our solution, how many pieces are we going to have? Three pieces. This bottom left piece, this middle piece, and then that piece. Everyone okay with that? All right, so negative infinity. Okay, to our asymptote at -3 with a parentheses. Union. Okay, almost, but since this is just a less than sign, not a less than or equal to, we're still going to use a parentheses. Okay, but here's that -2 value with a parentheses. Up to what x value? 2. And then picks up again where? At 3 for our intersection point to infinity. Questions on that? All right. Number 4, I'm going to have you try on your own, but I do want you to please change the less than sign to a greater than sign because we haven't done any greater thans, and I just want you to have some practice with it. So change the less than sign to a greater than sign, please. And then I would like for you to try it on your own. Okay, which expression represents our rational function? Yes, this one right here, 1 over x plus 3, represents our rational function. Why? Good, x is in the denominator. So our rational function is our curved shape graphs. So it's going to be here to there. Okay, our linear function is 1/2 x plus 7/2. Is that a horizontal line? No. No. 1/2 x plus 7/2 is not a horizontal line. All right, so since we know that 1/2 x plus 7/2 is not a horizontal line, it can't be that line. What does that line represent? Yeah, that's our horizontal asymptote of our rational function. So this diagonal line is what represents our linear function. Everyone okay with that part? All right, so we are looking for when the rational expression is what? Greater than or above the line. So that's going to be this portion. And it's going to be this portion. Where's the vertical asymptote in this graph? Good, x equals 0. would be our vertical asymptote. All right, so our solution is going to start where? Negative infinity. And go up to what x value? Negative 2. Parentheses or bracket. Parentheses, because it's not equal to. And then union, where are we going to start again? At 0 at our vertical asymptote. And then up to 1 with a parentheses again. Questions? Cool.